Hello, everybody. Welcome to special Zoom session on a very special snow day. I hope everybody can see the right screen here. And we're going to do activity 7 that we were supposed to do on the 31st, but we didn't have time. And we're going to get started right now. In both of these reactions, the alpha position of the aldehyde, this would also work for ketones, but in both of these reactions, the alpha position of the aldehyde has a replacement of a hydrogen with, in this case, a deuterium. And in this case, both alpha hydrogens are replaced by deuterium. One is an acid catalyzed mechanism, this one. I apologize, on the original document I gave you, there was a hydrogen here. That would not destroy this reaction, but it would slow it down because this hydrogen would transfer here and you'd get the same result. As we progress in this mechanism, I'm going to point out the fact that there's a Rassomization going on. So the word Rassomization reflects that you're taking one isomer and you're going to make a mixture of two isomers, R and S, equal amounts, racemic mixture. This one doesn't have a stereocenter, so not relevant to talk about Rassomization. When you see an acid catalyzed mechanism and you need to do a reaction at the alpha position, you have to remember this one fact. You need to do the keto-enol tautomerization first. So what happens in tautomerization is that we do our protonation of the carbonyl. Oh, that's not the thing I want to draw with. There's a pen. There's a red pen. Lone pair protonates with the strong acid. This is deuterosulfuric acid, if you want to know its name. In the second step, the tautomerization with sulfate ion. Which you're going to make during this first step will be in a separate color because it happens next. I'm trying to get the bottom of my screen issue. There we go. Here we go. Here we go. Now, if you prefer to do the tautomerization mechanism that was discussed in chapter 7, where I don't break it up to 2 steps, that is perfectly fine. But please do remember that in Chem 241, you weren't ready to combine steps. So here would be the 2-step process that gets you to the enol. So here's our enol. And the important thing about the enol is it's sp2 now. The alpha carbon is sp2 now. So it doesn't have stereochemistry. And we're just going to do the reverse process because this is also tautomerization, just in the other direction.
Shouldn't it be a D instead of an H?
Oh, yes. Thank you for that edification. That should be a D. Thank you so much. We'll make it a black D here. Yeah. And we're going to use the same acid-base pair. I don't even see the reason why we have DOD here, so we don't really need it. So if I give this on a test, I'm not going to have DOD there. Let's get my old eraser going here. We haven't used it yet, and we're not about to use it either, is what I'm trying to say. We've got our DOSO3D, and here it is. We just made it after we used it. And its conjugate base. And the conjugate base, we'll grab that D. Sigma becomes pi. And 50% of the time, it'll pick up a deuterium from in front of the molecule. Because this is flat. It's flat. It'll either get it from the front or the back. And when it gets it from the front, it goes here. And if it gets it from the back, it goes to this with a D here, which would be the enantiomer. And the other half of the time, it'll pick up this D from behind and give a dashed D here and a wedged H here, or a methyl here in this case, sorry. And yeah, these are both reversible reactions. So in the end, you end up with a 50-50 mixture of this one and its enantiomer. 50%, and this one is, it's a nice percent. This one goes 1, 2, 3, which is wrong because that's 4. So it's not R, it's S, and 50% R, the other product.
Do we have to show you that on the exam?
No, just the arrows and the one intermediate. And if you choose to use the 2 colors or whatever, you've got to acknowledge that it's 2 steps. Protonation first, right?
Yeah.
That seems to be consistent all through the course, doesn't it? All right. Now in this one, we're going to do the base catalyzed version. And the base is strong this time, so you don't have to wait to protonate the O. The base is already a strong reactant. OD minus right here. And it grabs the H. Now in this one, you can go to the enolate, which is the O minus, or you can just dump the minus on the carbon. Don't care which one you choose. So here I'm putting the minus on the alpha carbon. Go straight to equilibrium this time because this is also equilibrium. And you got a lone pair and a minus. And you're going to pick up a D in the next step. These are not hard mechanisms, so nice, easy finish to the chapter. And you did it once. We'll do it again. Still have an H. And still have OD minus because you made it again. Same mechanism. And I'll also I'll also talk about the other option I just verbally talked about, where you have the double bond between carbons called an enolate. And if you want to finish this one off, DOD again. Well, went right into that D, didn't it? And there you have it. Save that. We'll give an alternate where I resonate with the carbonyl instead of putting the lone pair on this. And it'll give a better resonance form. So let's be clear, this is an alternate for this top one. All right, well, let's try to simulate it. You just need a big fat pen here. There we go. Alternate for this one. Trying to move that over. Wow, it's like doing battle here. Go with the mouse. Okay. Alternate. Don't need those wedges or dashes. Don't need the aldehyde H. You get your OD minus. Grab the H. Yeah, try red. Get off the bottom of the page. Resonate instead. Also an equilibrium process. This way it's going to look a lot like the top mechanism. We've got that. Grab DOD using that. Grab a D. DOD. Resonate back. Got your first D on there. And I'm not going to finish the mechanism. You're just going to do exactly this again with this, the H that remains. Sorry, I forgot to put a D on there. You're just going to do it again with this H. So I'll show that it's got 2 more steps. And you're done with that one. Give you the big picture here. And that's all we have. Do any have any questions for the end of chapter 16? Because I know you want to review all weekend and next weekend. So I'll open up the chats to see if there's anything there. And you can chime in if you want. Otherwise, I'll just say have a great weekend, everybody.
Yeah, just the exam is not next week. It's the week after, right?
That's right. Not Monday, but the Monday after.
Okay, yeah, that's all. Yep.
I believe that's the one we corrected the syllabus to, right?
Yeah, February 14th.
Correct. All right.
Thank you.
So enjoy your snow day, everybody. I made
Thank
this
you,
for
Dr. Whitaker.
Thank you.
Have a
Be
good
safe.
weekend.
You
Bye-bye.
too. Be safe. Thanks. Bye.